This is What the Hack 15's check-in number 7, where we will discuss the progress we have made this week, which are the continuation of the UI design process and also planning and testing connections to the back-end logic to the front-end presentation layouts we created in Android Studio.
This week we started recreating the Figma wireframe in Android Studio layouts for the application user interface. We added several screens that are in the Figma wireframe and began to connect the compression data collection methods to the front end, while keeping in consideration the design requirements and evaluation criteria from the previous week and earlier phases of the user interface design process.
A quick recap of the timeline of the design process. Last week, we created the medium fidelity prototype, which was made in Figma, and evaluated it according to Don Norman's usability principles of feedback, constraints, mapping, affordances, visibility, and consistency. The week before that was the individual and group brainstorming. We used the output of these phases of the project to begin the actual creation of the user interface in Android Studio, which is the last of the 6 phases we have outlined in the earlier weeks. Despite being 6 phases, the process is iterative. Once we have a functional application created, we can evaluate it and make changes if necessary after brainstorming ways to implement them and evaluate their feasibility or how well they address any issues found.
The first UI layout created was the main menu screen, which has several buttons on the right-hand side to toggle slow mode, view the tutorial, toggle a compression status after 10 compressions, which are the last few depths and average, as well as the button to begin the compressions. On the left, we have a signifier to the user on where to hold the device to get the best results.
In order to ensure the logic for tracking compression rate and depth is working appropriately, we've produced a version of the application that displayed the core metrics, including individual compression depth, average compression depth, recent rate of compressions, which includes the 3 most recent compressions, and the average rate of all compressions, as well as the compression count. By doing this, we are able to observe the data that is being tracked and returned via real-time testing. On the right-hand slide, we can see another more simplified version of estimating distance traveled by the phone via contact of the 2 pieces of tape situated at specific distances.
The distance traveled in this demo is 2 inches between the start and stop points marked by the tape. The compressions per minute are 110. Testing was performed at 1 inch and 2.5 inches as well. Although not shown here, the same testing was also performed on the 3D printed CPR device. Both modalities have yielded similar results in terms of precision and accuracy with the measured depths thus far.
Here we see a demo displaying the user interface for the core functionality of the application. The UI displays to the user if they are on rate via the game UI. When the user is performing compressions at the appropriate rate, the display will then confirm if compressions are correct, or too deep, or too shallow. Finally, we see a results screen that provides a percentage of the compressions that were in their target zones for rate and depth.
Next week, we will continue adding functionality to the app UI. This includes merging the main menu screen components and training screen, providing feedback via sounds and vibrations, and incorporating toggle features such as slow mode. In addition, we will be testing the application at different depths and rates, as well as testing the UI for appropriateness and ease of use.